Hey everybody, welcome back to my channel. And as you can see, this is going to be the first episode for deep learning. And whatever I'm going to talk talk about deep learning is purely out of whatever I've understood so far with the lot of courses that I've taken up till now. And just a small disclaimer: this series is not going to be uh, talking with reference to all the people who have zero experience about deep learning. It's going to benefit the people who have at least intermediate level of understanding of deep learning. And yeah, without any further ado, let's begin. First things first, what is deep learning? So here's a definition from IBM. This is what they said. Deep learning is a subset of machine learning that uses multi-layered neural networks and multi-layered neural networks called deep neural networks to stimulate the complex decision-making power of the human brain. Now, that's very self-explanatory. Now, what it means here is inside ML, you have your deep learning, and inside that, you have your AI. So basically, everything is ML. You can call it that. Now, let's talk about where we can actually use it. Now, where we can use it is called the applications. Now, for that, you have first things first. The first thing that popped up into my head was healthcare. Now, if you guys are wondering where the hell do we even use deep learning in healthcare, your answer is in detecting tumor detection, or cancer detection, and many more. And let's talk about the second application, which is going to be your agriculture. Agriculture. Ah, yes, correct. Now in agriculture, seed health, seed health. So if you take a picture of one seed and you deploy it inside your model, it's going to tell you whether your seed is healthy or not based on size, uh, color, and many other factors that are trained in the model. Next, you can also talk about water, something related to water. Maybe talk about uh, how much water is required for this day based on weather conditions, etc. And the third most interesting topic for application is your self-driving cars. Now, this small deviation from the topic is for the people who are very curious about how it actually works. Now, let's take in a small depiction of how a car will look like. And you have one sensor on top there in front, one on top, one at the back, two at the side here, and two at this side here. Now, let's talk about its field of vision. It's like white. Now, this will have a field of vision of this with that, this with that, this, uh, this small correction, and that. Now, the only area where you do not have a field of vision is this, the one that I marked with red, and where you have field of vision is everywhere else. Just a second. Now, the reason behind why there is no sensor at the side, at the center of the car is to first thing is to reduce complexity, other is to reduce the expenditure on sensors. Now, there is no use of having a sensor here when your field of vision of your extreme ends are already covering this portion here. So if any vehicle is entering this, it's going to get detected anyways. So this purple dot and this purple dot is going to cover this portion. So you don't have to worry about your red area here. So this is a very high level understanding of how self-driving cars work. Now let's take one small example, a real life example, which is about your uh, house and a size of the house and the price of the house. So for that, let's take in white. Uh, okay, this is going to be your uh, y-axis, your x-axis, and your y is going to talk about price of the house, and this is going to this side your x-axis is going to talk about your size of the house. Now let's randomly just plot some points. All right, that doesn't look good. All right. Now, if you ask normal machine learning student to segregate this into two clusters, what is going to do is either do this and this, or he's just going to draw a straight line like that, which is not wrong. But once you enter into deep learning, you will learn about something called your ReLU function. Now, the difference between your linear regression and your ReLU function is that in your ReLU function, you have this buffer, whereas in your linear regression, you do not have that buffer. I will talk about ReLU function in detail, but here's what you can take away from this topic. So basically, what ReLU stands for is uh, rectified linear unit. This is what it stands for. We'll talk about this in the upcoming videos. Don't worry about it. This is what you can just take away from now, okay? And let's look now. Let's get into neural networks. All right. It's not a big jump. It's not even a jump. It's the immediate next concept that anybody would talk about. Now, for neural network, let's take the same example and jot down the features that we can extract from it. Features. Now, first thing is your size. We can take in size. We can also take in number of bedrooms, and we can also take in number of floors, for example. Yes, number of floors. Now, this is x1, x2, x3. All right. Now, keeping this in mind, let's draw a simple neural network. One, two, three. And you have your x1, x2, x3. Now, let's draw some relations or some network with it. This is going to be your A. This is going to be your B. It doesn't really matter. I'm just explaining it for now. All right. And finally, you have your Y, which is going to be your price. Now, looking at this, let us name, let's start doing a little bit of terminologies. All right. And for that, let's take in a different color. How is this? No, not good. Uh, maybe this. Okay, it's better. I'll take it for this. Okay. Now, let me just clear that out. This is going to be your X, this is going to be your Y, and uh, yeah. So, in other words, these are your input features, and this is going to simply be your output. And this set, for this example, we made only one set, but in many cases, or mostly all the cases, it's usually going to look something like this, with two or three, mm, like you'll find a lot of circles all around here. All right. So in this case, we have one layer, but in this case, you have one, two, three layers, right? Let's clear that out so you guys don't get distracted. All right. So any layer between your input feature layer and your output layer is called your hidden layer. Wait, my hidden layer. Now, each unit inside a hidden layer is called your, yes, you guessed it right, hopefully, your hidden unit, or if it's two hidden units. All right. Now, this is a terminology that you guys can take away from this portion. Let's move into a simpler, not simpler, a slightly practical based approach on where we can use supervised machine learning or supervised deep learning. Let's take in input features as X, output features as output as Y, and the application for that. All right. Now, if we have home features, number one, home features as your input, such as size, number of rooms, etc., as your input, and your Y is as your price, the application for this set would be into real estate. Real estate. And let's talk of as a next example, which is if you have ads, advertisements, user information as your input features, and Y as the number of clicks, then that would get into advertisements. And the third one, let's talk about if you have image as your input features and Y as your object or objects to be precise, that would get into application called photo tagging. Now, let's say you have an audio file as your input. Now, this is going to, let's say you want to convert it into a text. This is going to be your machine translation. Translation. And last but not the least, let's say you have uh, an image plus radar. Wait, let me make it a bit clear. Image plus radar, and you want to find out the position, basically a GPS. So this application would be used into self-driving cars. Now, with this, I think this covers the broad spectrum of all the applications that deep learning is used. Now, if we are asked to classify all these applications into certain categories, this is what we would do. This as actual neural networks, photo tagging, convolution neural networks, and this RNN, and this is a mixed hybrid, which is basically a mix of maybe NN, CNN, and RNN, or maybe just NN, CNN alone, and likewise. hybrid. Just different combinations of different other categories there. Now, after this topic, this topic is going to be a very short topic. Now, you oh my God, you're always dealt with two types of data here. One is your structured and your unstructured. Now, in structured, we have examples such as tables, uh, what else? Lists, dictionaries, and so on. Whereas in unstructured, you have audio, uh, and image. Just let me know if I missed some more, but yeah, this basically covers it. Now, the reason why everybody's moving into deep learning nowadays is because uh, mainly three reasons. Number one is going to be your, just a second, why deep learning now? So the number one answer for that is we have, whoa, what's that W? We have a lot of data to work with. And number two is you have good GPU and CPU. And number three is, why is the V U there? Hold on. And number three is we have a lot of smart people. This translates into we have algorithms, new algorithms. All right. Now, yeah, this is the entire brief of your deep learning for your first lecture. I hope you have no questions. I mean, if you guys do, no worries. Just feel free to drop it down in the comment section. I will look into it and reply as soon as possible. Yeah, I hope you guys are satisfied with it and make sure to leave a like and subscribe. Take care. Have a nice day. Bye bye.